Hello everyone, welcome back to the channel. And for this video, we are gonna do a home lab in Packet Tracer to culminate all of our learnings from CCNA section 1.0 Network Fundamentals. So we are gonna apply everything that we've learned in that section. So this home lab is Network Fundamentals Part 1. And for the lab overview, we are going to build a 3-tier enterprise network with a core distribution access layer, assign IPv4 and IPv6 address, and add wireless connectivity. And the network fundamentals topics that are covered in this home lab are router, switches, access point, PC, server, and laptop from section 1.1, 3-tier topology from section 1.2, fiber and copper cables from section 1.3, IPv4 address and subnetting from section 1.6, IPv6 address and types from sections 1.8 and 1.9, and wireless connectivity from section 1.11. And to do this home lab, the requirements are Packet Tracer and your CCNA 1.0 Network Fundamentals knowledge. I'm also going to add some question and answer portion while we're doing the home lab so we can review some topics and the CCNA network fundamentals. Also, there's a PDF document of the instructions available on the website at eastcharmer.com/resources under the networking home labs. If you want to follow along, this has the step-by-step instructions, the commands, and the topology. And it includes everything that we are going to cover on this video. Okay, so let's get started with our home lab, and we are going to do a 3-tier topology for this home lab. So just to review, what are the components or different tiers of a 3-tier topology? You have the access layer, distribution layer, and core layer in that respective order. So in this home lab, we are going to need 3 layer 2 switches for the access layer, and then 2 layer 3 switches for the core layer, and also 2 layer 3 switches for the distribution layer. Okay, so let's start by adding 3 layer 2 switches for the access layer. You can click the network devices on the very bottom left part and select the switches and drag the 2960 switches. Next is adding layer 3 switches for the distribution layer, and we are going to use the 3650 switches for this. And let's add layer 3 switches for the core layer as well, and we are going to use the same 3650 switches. We are also going to use a router as part of this topology, and we are going to use this router for 331. And next is adding end devices to our topology. Let's just go to the bottom left portion and select end devices. And select PCs, and we are going to add 3 PCs and 1 server in this example. So just follow this topology where the 2 PCs are next to each other, and next is the server, and next is another PC. Okay, so let's go to the next part where we cable all of the devices together. So in this home lab, I want us to practice different types of cable, not just copper cable in this Packet Tracer. We are also going to use fiber cables because that is what we really do in the workplace, and we are going to connect the core switches and distribution switches using fiber cables. Okay, let's get started, but before we connect the fiber cables for the core and distribution layer switches, we have to set up the layer 3 switches first because they are not set up the same as the layer 2 switches. For example, when I click on the layer 3 switch in here, we will have to manually add the power supply modules just like we do in the workplace. So if we compare the layer 2 switch to the layer 3 switch, we don't have to do any additional setup for layer 2 switch. It will just boot up when we connect cables to it. But for layer 3, we have to add the power modules manually. So if we zoom into the layer 3 switch, you can see that The modules here are blank, and we have to go to the module on the left side, select the proper module, and drag and drop it here. So let's go to the left side under the modules. Let's select the AC power supply, and let's just drag and drop it on the 2 slots below in here to the rightmost side. And as you can see, there is a power cord in here, which is what it looks like in the real world. Okay, so let's just do that for the rest of the layer 3 switches we have in our topology, and that's what you have to do when you're using the 3650 switch. Okay, and now because we are using fiber cables to connect the core switches to the distribution switches, we are also gonna have to add fiber modules on these switches, just like how we do it in the real world where we add the SFP modules on our switches. We have to do this because the ends of the fiber cable needs a special connector to plug it into the switch. So if you look closely into our layer 3 switch, it also has slots where you can plug in SFP just like the actual switches. Okay, so for example, we didn't have any connectors on these switches. Let's try to connect a fiber cable and see what happens. So on the bottom left in connections, we can select fiber in here. And let's connect it to the layer 3 switch on any ports, and you will get this error message. It will say the cable cannot be connected to that port because it doesn't have the proper connectors, so we have to add the fiber modules on these switches. So click on the layer 3 switch, and under the physical tab, we can check on the left side where the modules are, and the ones that we're gonna use in here is the GLC-LH SMD. That is the proper connector for our fiber cable in Packet Tracer. And we can just drag and drop it on the slots on top of the power supply. We only need 1 connector, but you can add up to 4 because it has 4 slots available. After adding the fiber modules, we can check if there's a change with our layer 3 switch. Just click on the fiber cable again, and then click on the layer 3 switch. And as you can see in here, there are additional ports that were added that wasn't here before when we started adding the layer 3 switch. These are the ports where we can plug in our fiber cables to. So just do the same for the remaining layer 3 switches. Just add the fiber modules so we can connect them with our fiber cables. Now let's try again if we can connect fiber cables because we are getting an error earlier. So just grab the fiber cable and click on the layer 3 switch. And let's connect it to the additional ports at the very bottom that are the SFP modules or the fiber modules now. And connect it to the switch right below it on the same fiber ports. And now as you can see, we can use the fiber cable now to connect these layer 3 switches. Okay, so let's now do the same and connect this core layer switch to the distribution switch. And now we have connected our core layer to the distribution layer using fiber cables. And now we can cable the rest of the devices together, and we can just use a copper straight through cable on the access layer to connect to the endpoints, like from access switch to the PC. So let's go at the bottom, make sure that connections are selected, and just select the copper cable. And let's just connect the computer to the access layer switch and just connect it to any fast Ethernet port. And let's do the same for the rest of the end devices, and the second PC should connect to the first switch. The server should connect to the second switch. And the third PC should connect to the third switch. Let's now connect the access switches to the distribution switches, and we are still going to use the copper cable. So when we're connecting the access switches to the distribution switches, just make sure that you are connecting it to the gigabit port, not the fast Ethernet port, because these are the uplinks, and when we are connecting 2 networking devices together, we are using the gig port. And just connect the second access switch to the first distribution layer switch, and the third access switch to the second distribution switch. And lastly, we will also connect the router's interfaces to the core switches. So one interface goes to the first core switch, and the second interface goes to the second core switch. Okay, now that we have connected them all together, let's go to the next step, which is configuring the hostname for all of the networking devices. So let's start with the first access switch. Let's just click on it and let's go to CLI, or the command line interface, and just type in EN short for enable to get to the user privilege mode, and type in conft to get to our global config mode, and just type in the command hostname and give it the name access1 for example, and press enter. And just do the same for the rest of the switches. Just give them the names access 1, 2, 3, distribution switch 1, 2, core switch 1, and 2. And for the router, it's the same. We are also going to give it a host name. So if you click on the router and go to the command line interface, it's going to ask you if you want to enter the initial configuration, and just type in no for this. And type in en and conft, and it's the same command. Just type in hostname and give it the router 1 name. You're also going to give it interface descriptions because that's best practice. At least we would know what the interfaces are for. So type in int and the interface of the port. In this case, it's gig 000, enter. The command is description, and just type in what you want to describe it, like connection to distribution switch for example. And just do the same for the other interface. Just make sure you know the port where you will apply this command to, and it's the same description command. You can also just press the arrow up on your keyboard so you can get to your history and past commands, and just change the port number of the interface in here, and also just change the description to make it easier. Okay, so the next part is IP addressing. Since we have 3 networks in here, we are gonna subnet an IP address to 3 different networks, so we can also practice our subnetting skills. But I will not show you how to subnet on this video. You can do it on your own and practice your subnetting skills. So in this lab, we are subnetting the IP address 192.168.100.0/24 into 3 networks. And once we're done subnetting into 3 networks, we are now going to assign the IP address based on the appropriate subnet. So PC 1 and 2 will be on subnet 1, the server is on subnet 2, and the third PC is on subnet 3. And to assign the IP address, just click on the computer, go to desktop, and select IP configuration. And in here, this is where you can type the static IP address of every end device. For PC1, we can type in 192.168.100.10, and for the subnet mask, since it's gonna change, it's now /24. The subnet mask will be 255.255.255.192. Since the second PC is on the same subnet as PC1, we can use IP address 192.168.100.11 and same subnet mask .192. Let's now move on to subnet 2 for the server. It's gonna have a different IP address. So for subnet 2, we can use the IP address 192.168.100.74 and subnet mask is still .192. And my third PC is on subnet 3, so we can use the IP address 192.168.100.130 and same subnet mask .192. Okay, so after assigning IPv4, we are now going to assign IPv6 IP address, and the first IPv6 address that we're going to assign are the link local address. So in our home lab, we are also going to practice our IPv6 skills. So we are going to do different types of IPv6. And the first one is the link local address. And just a review question, what is a link local address? So link local address allows the device to communicate on the local network and they are not routable off the network. Okay, let's get started configuring IPv6 link local address on the computers. So this is very important to remember that by default, a device already has a link local IPv6 assigned to them. So we can check on the computers and see if they really have this link local address. So if we click on a PC and go to IP configuration, below the IPv4 settings, we can see the IPv6 address, and as you can see, there already is a link local address that is assigned in here. We didn't have to put anything in here. This is already available if we add a new computer or a new end device on our packet tracer. So I have a follow-up review question. If we see an IPv6 address, how do we know if this is a link local address? It's link local if the rest of the address are generated using the MAC address. So we can check the MAC address using the ipconfig/all command to see if the IP address is indeed generated from the MAC address. So we can close out of this IP configuration window and we can select the command prompt here, and we can type in the command ipconfig/all. And that's how we can check the MAC address of a computer. And as you can see from the result in here, sometimes it doesn't say MAC address, but it would say physical address, and that's the same as the MAC address. So that's what we're looking for. So if we look closely, we can see the physical address, which is the MAC address in here, and right below it is the link local IPv6 address. And if we compare these two, look at the last bits in here, they're the same, and we can see that this link local IPv6 is derived from the MAC address. Okay, so another review question. What do we call the method where we generate the IPv6 address from the MAC address? Okay, so this is called the modified EUI64. Okay, so now that we know that all of the computers have their own link local address, let's test the connectivity between two computers. Okay, so let's test connectivity between two PCs on the same switch. First, we can ping the IPv6. So what we can do is go to the IP configuration and then copy the IPv6 link local address, and then go to the other PC and ping it from that and see if we can ping them or we can reach them. Okay, so as you can see, we can ping the PCs on the same switch. Now let's test connectivity with a PC on a different switch. Okay, so let's now go on a PC on a different subnet, like the third PC in here, and let's copy its link local IPv6 address. And let's go back to our first PC, which is on a different subnet, and let's ping the third PC from there and see if we can get connectivity. Okay, as you can see, it doesn't work and it's timing out. So review question, why doesn't it work? That is because it's in a different network, and link local is not routable to different networks or subnets. Okay, so let's now configure the router with a link local IPv6 on its interface. Okay, so this is very important to remember that IPv6 in router is disabled by default. Okay, so let's go to our router and let's enable IPv6. So we can type in en and then conft, and then we can use this command IPv6 unicast routing, and this command enables IPv6 on the router because without it, IPv6 is disabled by default. Okay, so next let's configure the router interfaces with the link local address. So first, we need to know what port we're going to use to configure the interfaces. We can just hover and see what port it's using, like G000 in here, for example. And let's go back to the command line and we can type in interface G000. And to configure the link local address, we are going to use the command IPv6 space address space the IPv6 address that we are using. In this case, we are going to use the FE80::1. So the FE80 prefix is used for link local unicast address. We also just use ::1 to make it simple and easier to type and to remember. Then after the IP address, we are gonna do space and then link local command, and this command creates a manual link local address. This address is just locally significant and no need to uniquely identify one network to another network. And the next command is no shut because the router's interfaces are
disabled by default and we have to manually enable them. So you can see in here in our topology, the interfaces are red because they need to be enabled. And just do the same with the other interface. Just type in the IPv6 space address command. And you can also use the same FE80::1 IP address. Okay, so next is configuring the PCN router with routable global unicast address. So to make this lab easier, I'm just going to give you a global unicast address that you can use to assign on the computer and the router. Also, just a tip to make it easier for labbing, you can place a note of the IP address so you can just reference it later when you're pinging it or you're configuring it. Okay, so the global unicast address that we can use is 2001:db8:1:1/64. Okay, review question. What is the prefix 2001 for? This prefix is used for documentation and tutorial purposes, so we can use this in our home lab, but we can't use this when we are in production and if our networks are operational. Okay, another review question. What does the first 64-bit represent in this address? The first 64 bits is the network portion. And another review question, what does the last 64-bit represent in this address? The last 64-bit is the host portion. So this is the global unicast address for our router interface 1. Let's just move it right next to the interface. And for router interface 2, we can use a similar IP address 2001:db8:ACAD:2 because it's on a different network, and ::1/64. And we can now configure the IPv6 address on the interfaces. So if we click on the router and go to the command line interface, let's type in int gig000 to get to our first interface. Then let's use the command IPv6 space address and then space the IPv6 address of our first interface, which is a 2001 ACAD:1:1. And don't forget the /64 and just press enter. And that's how we can add an IPv6 address on an interface. And just do the same to the other interface. You can press the arrow up button to show the history of your command and just replace the 0 with 1 and press enter. And then do the same, press arrow up and then just change the IP address for this command. And press enter and you should be all set with the IPv6 for the interfaces. And we can also verify if the interfaces indeed got the IPv6 address. We can use the command show IPv6 interface and the interface number or the port number. And if you are in the wrong mode, just add a do on the beginning of the command and it'll force the command to do the verification. And here is the result, and we can see what the link local address is, and we can also see what the global unicast address is assigned to this interface. So this is how you can verify or check what IPv6 address were assigned to the interface. Okay, so let's now move on to the next part, and it's setting up the global IPv6 address on the computers. So now we can click on the computer, and under the desktop tab, we can select IP configuration. And we can select the automatic under the IPv6 configuration, and it will automatically configure the IPv6 address and the default gateway. And this is very similar to the HCP for IPv4. Okay, time for a review question. What method is this automatic addressing using? This is called Slack, and it's a method that allows IPv6 devices to automatically assign themselves an IP address without needing a DHCP server. So as you can see in here, we have successfully generated an IPv6 address and also a gateway. And if you recall, this is the same link local IP address that we have assigned the router interfaces. So the router's link local IP address can also act as the default gateway. So now we can test the connectivity and see if we can ping across the network. So just take note of the global IPv6 address from the computer you want to ping, and then click on the computer where you're pinging from. And this computer should be on a different subnet or network, so we can test if our global IP address is working and if it's routable. So under the desktop tab, click on command prompt and then just ping the IPv6 address in here. And as you can see, we can now reach the other computer from a different network using the global IPv6 address. Okay, so for the last part of our home lab is configuring a wireless network. So we are going to add an access point, and at the bottom left we can go to the network devices and select wireless, and just select the AP device in here and drag it right next to the last access switch on our topology. And let's connect the access point to the switch using a copper cable and just connect it to any ports on the switch. Next is let's set up the SSID for the wireless network. So just click on the access point, click on the config tab, and under the interface you can see port 0 and port 1. Port 0 is for wired connection and port 1 is for wireless. So we are going to choose port 1 because we are going to set up a wireless network. So this is where you can set up the SSID, and let's just type the SSID that you want in here. I'm just typing East Charmer. You can type anything you want. And the next step is to set authentication to WPA2 PSK because that is the best authentication that we can choose from the options. So just go ahead and select WPA2 in here, and this option would require you to enter a password. And just type in the password that you want in here. And we can close this window now and move on to the next step. So the next step is to add a laptop to configure the Wi-Fi settings. So at the bottom left, we can select the end device and just select the laptop and drag it. So now we can configure the laptop. Just click on it. And then the first thing we're going to do is to add a wireless module because this laptop doesn't have it. It just has an Ethernet port. So if we zoom into the laptop in here, we can see that it only has an Ethernet port, and we have to add a wireless module so we can connect to our access point. So what we have to do is remove this Ethernet port, but before we can remove it, we need to turn off the laptop first by pressing the power button. And once it's off, we can just drag the Ethernet port to the left side so it removes it. And on the left side in the modules, we can look for the WPC300N because that is the wireless module that we're going to use. So just drag and drop it to the blank slot in here, and now we have a wireless module. And don't forget to turn the laptop back on. Next is go to the desktop tab and select PC wireless, and now let's wait for the SSID to show up. Sometimes it takes a minute to show up, and just click on it when you see it and just click on the connect button. And just type in the password and just click on the connect at the bottom. And if we close the window, we can see that the laptop is now connected to the access point wirelessly. Now let's go back to the laptop and check on the IP configuration. And as you can see, there is already an IPv6 global Unicast address assigned into it. So we can use this address to ping the laptop from the other computers if we want to test connectivity. So that concludes the home lab for this video, and we covered a lot of topics from the network fundamentals section. If you're interested in more topics about network fundamentals, we are going to add more to this video and topology. So please stay tuned if you want to see that and you want to follow along. If you have any questions, please let us know in the comment section down below. And I hope you learned something from this video, and I hope to see you guys in the next one. Thank you so much for watching.